Yeah, we're good now.
Okay, cool. Let's get back.
This race brought to you by Visa, the official card
So let's back up.
of the NFL, and the only card accepted at the
All right, so the current fastest person alive today is Usain Bolt. Everybody knows that. So the question is, who was the fastest person before? It was debatable. So it was either Maurice Green or Michael Johnson. So this is what people were debating.
games. And the Visa Triple Crown. Almost forgot. We are also the official card of NASCAR. Visa, it's everywhere you want to be.
All right, so the first thing we need to do is figure out a way to define it. So a simple definition is a displacement of mass. All right, so something is going to go from point A to point B. So it takes time, obviously, for it to go from point A to point B. And it's actually moving in space. So displacement of that something, which is known as mass, in space and in time and in space. Everything that you're seeing here in red are everything that we get to measure in terms of describing motion. Oh, let me check to see how well this works. You can spotlight this. And downward. Yeah, whatever. All right, so motion is a displacement of mass in time as well as in space. All right, so we need to be able to express mass, time, and space in terms of numbers in describing motion. All right, the easiest one here is time. Let's start with time. So how do we define time with physics? Time. We have to describe time in the way we measure it. Time. Is that a human invention, or is this something that we get from nature itself? What do you guys think? Any ideas?
I feel like it has to do with nature, like when the sun rises and the sun sets.
Okay, very good. Yeah, I'll give you 5 points for that one. Yeah, absolutely. As we get time from nature itself, right? Nature goes in cycles. All right. It takes a year to go around the sun. That's your time. Every time the Earth goes around the sun, obviously we get older. And then you take that 1 year, artificially, you can break it into 4 seasons if you're lucky enough to experience 4 seasons. I'm currently in Chicago. You guys are in Visalia. In Visalia, you only experience summer and some kind of spring, I think. Here we experience 4 seasons. And then you can take a 1 year, break it into 12 months, months into weeks, weeks into days, days into hours, minutes, seconds, and so forth. All right. So we get time from nature itself. That's the philosophy of time that you're looking at. But how do you describe time in the way we measure it? Einstein is the guy who came up with the best definition or expression for time. He said time, whatever it is, it's what's measured by a clock. So we will express time in the way we measure it. We measure time using a clock. So what's measured by a clock is what we refer to as time. All right, notice that we came up with a definition of time. So a couple of things we've done here. All right, so what's motion? The short answer is displacement of mass in time and in space. So that's what we came up with. So question number 2, what are the only measurable quantities in describing time? Measurable quantities in describing time is mass. But no, well, what are the measurable quantities in describing motion? So mass, time, and space, that's it. How's time defined in physics? What's measured by a clock? Skip question number 4 for now, so we'll get back to it. All right, pick out the best answer. How's time defined in physics? What do you guys think? All right, Elisa. All right, so you said B, right? If you had to pick between A and B, I think that those are the ones that we discussed. Which one makes more sense? How's time defined in physics? We're looking for the definition of time. We don't care where the idea comes from. We know that there's time, and we acknowledge it, and we define time in the way we measure it, right? So those of you guys who pick B, give yourselves 2 points. Elisa, give yourself 5 points for saying B. Space. How do you define space? What is space to you? What does space mean to you, guys? It could be a volume. It's 3-dimensional, so volume has space. Area has space, which is 2-dimensional. So, or it could be a spatial displacement. It could be a 1-dimensional thing. You can go from point A to point B. So what is the best definition of space? Regardless of how you're defining it, it could be 3-dimensional, it could be 2-dimensional, it could be 1-dimensional. Each and every single dimension needs to be measured. Once again, Einstein is the guy who came up with the best definition of it. Einstein said space is what's measured by using a measuring stick. So the best definition of space is what's measured by like a yardstick or a meter stick. So space is what's measured by a measuring stick. All right, what's measured by a measuring stick? All right, now we get a definition of space. So time is what's measured by a clock. Space is what's measured by a measuring stick. So the next thing is what is mass? All right, those of you guys who want to say something at this point. What jumps into your head regarding mass? Time is what's measured by a clock. Space is what's measured by a measuring stick. So which means that the mass must be, what is mass? At this point, I know what you guys are thinking. You're thinking that mass is what's measured by a scale, right? That's what you're thinking, but that's not how mass is defined. What you measure using a scale is your weight, not necessarily your mass. Your weight is the amount of gravity acting on it. The weight is the measure of gravity. The definition of mass is slightly philosophical. All right, so this requires a little bit of understanding, a little bit of patience. All right, don't write it down immediately. Let's just discuss the meaning of mass. So number one, the book definition of mass is the measure of inertia. So the measure of inertia, what's the meaning of inertia? Newton is the guy who came up with this, roughly about 350 years ago. And inertia is the tendency of an object to retain its initial motion. And what's meant by motion is velocity. Velocity is a combination of speed and direction. All right, so this is the book definition of it. The book definitions really don't make a lot of sense unless you're a physicist. So we have to come up with a better way of expressing it. So what's mass? Obviously, the mass is measure of inertia. What's inertia? Tendency to retain initial motion. What's motion? Is velocity. This approach is not the best approach. Let me explain it. All right, so let me give you a better sense for what mass is. Mass is measure of inertia, but what is inertia? Now, just imagine yourself getting hit on the face by a fly at 60 miles per hour. So how fast is the fly hitting it? At 60 miles per hour. What does that feel like, getting hit by a fly at 60 miles per hour? It's going to be a slight pinch on your face. Do you have to go to a hospital because of it? Not really. I mean, what happens to you? Nothing. What happens to the fly? You got to find it back. Fine. How about a train hitting you at 60 miles per hour? What does that feel like? Well, it's not going to feel like anything. Fly, you will feel at 60 miles per hour. Train, you will not feel it. It's going to be a permanent out-of-body experience. Impact lasts only 1,000th of a second. Too short for you to be able to feel it. You will break apart. It'll kill you. It's going to be death. That's going to be dead upon impact. That's it. There's no way you can survive something. So what's the difference between getting hit by a fly at 60 miles per hour and getting hit by a train at 60 miles per hour? Fly comes to a stop, train is going to keep on moving as if you were never there. It's the mass, right? So which one is a larger tendency to retain its initial motion? The one with the larger mass. All right, so what is mass? In this case, mass is that measure of tendency to retain that initial motion. So the mass is the measure of tendency to retain that speed at 60 miles per hour. So where do you get that tendency from? You get that tendency from the mass itself. All right, so what's mass? The measure of inertia. If you could just measure that tendency, it becomes mass. All right, so Newton is the guy who came up with that. Inertia is the tendency to retain initial motion. And the motion means velocity in this case. It happens to be a combination of speed and direction. That's it. All right. Let's go back. Space is what's measured by a measuring stick. Skip 6, we'll get back to it. How's mass defined in physics? It's a measure of inertia. What is inertia? Tendency to retain initial motion. Just copy down the example of fly versus a train. Getting a person getting hit by a fly versus a train. That's it. You should be able to remember that. In terms of describing motion, there are 3 things that we need. Motion is going to be described in terms of displacement of mass, in time as well as in space. And those are the 3 things that we should be able to measure directly in terms of describing motion. So this is going to be our mass, this is the object. That's going to get displaced in space as well as in time. All right, so it's going to move going the x direction. It's going to be located here at a later point in time. And it's also going to take time for it to move that distance. All right. So m is going to be our mass. X is going to be our displacement or distance. And t is going to denote time. Time is going to be expressed in terms of seconds. Distance is going to be expressed in terms of meters. And mass will be expressed in terms of kilogram. These are the standard international unit systems, otherwise known as the MKS unit system. MKS unit system. M stands for meters. K stands for kilograms. S stands for seconds. MKS unit system. Meters, kilograms, and seconds. All right. So what's motion? Displacement of mass in space and in time, right? So the only measurable quantities in describing motion, you got mass, you got time, you got space. How's time defined in physics? What's measured by a clock? What's the proper unit? It'll be seconds. How's space defined in physics? What's measured by measuring stick? What's the proper unit? It's gonna be meters. How's mass defined in physics? Measure of inertia. What's the proper unit? Kilograms. What does MKS stand for? Meters, kilograms, and seconds. All right, so let's move on to the next topic. The next topic is going to be speed. What is speed? Speed is how fast an object moves in space and in time. So it is how fast an object moves in space and in time. All right, so how fast an object moves in space and in time. It's going to be directly. It's how fast an object moves in space and in time. That's the basic definition of it. All right, so we'll have an object moving in space and in time. So I'm going to use the same setup. Okay, so let's take this and then let's use that. All right, so we'll use the symbol V for speed. And the object is going to get displaced. All right, so the object is getting displaced in space as well as in time. So how fast the object gets displaced in space and in time is your speed. All right, so speed is the ratio between distance over distance and time. Okay, once again, x is your distance, expressed in terms of meters. T is your time, expressed in terms of seconds. And v is the speed. It's going to be distance over time. So distance is going to be expressed in terms of meters. The time is in terms of seconds. So which means that the speed will be meters per seconds. We use the British unit system in the United States. And in sciences, we will get to use the metric unit system. So which means that we will do tons of conversions. And here's the conversion factor. All right, so speed is how fast an object moves in space and in time. Okay, so pick out the best answer for this one. In the MKS unit system, the velocity and or speed is measured. All right, so what's the best answer for this one? The best answer is all right, Kamar.